What's happening, y'all? Pasek here. In this video, we're going to be discussing in some more detail the connection between the original function and its derivative, and vice versa. So far, we've really done that graphically, not so much analytically. And in this one, we're going to do this a little bit more analytically. So without further ado, it says for each of the given functions, determine the intervals on which f of x is increasing or decreasing. And then we also got to find all coordinates of the relative extrema. The relative extrema mean what? Minimum, maximum points. Unless otherwise noted, perform the analysis on all values from negative infinity to infinity. Provide justification for your answers. So in this one, we're dealing with a sinusoidal function and a linear function combined. And we are told only to look from 0 to 2 pi. And the most likely reason for that is because otherwise, there would be infinitely many places where we'd have to look because of the cyclic nature of sinusoidal functions. So, let's do this. So the first thing we're going to do is find the derivative. So I'm going to do that and be right back. All right, so my derivative, is f prime of theta equals 1 plus 2 cosine of theta. And the reason I got that was because the derivative of theta is 1. It's a linear function, so its derivative is constant. And the derivative of sine is cosine, so we just leave the coefficient there. So that's the first step when we're trying to find these intervals of increasing and decreasing and the coordinates of relative extrema. The second step is to find where the derivative equals 0, because where it equals 0 are the possible places where the derivative went from positive to negative or negative to positive. Pardon me. And those are the locations where the original function could have a maximum or a minimum. So let's set this equal to 0 and solve. So I took a little pause there and I did this. I set 0 equal to 1 plus 2 cosine theta. Subtract 1 from both sides, divide by 2 on both sides. We have cosine theta equals negative 1/2. Well, I need to know what theta is. So I don't know what you remember about the trigonometry part, but basically when you're trying to find an angle inside of a trigonometric function, the only way to get that angle is to do the inverse trig function. So we're going to need to perform cosine inverse of negative 1/2. So I have to ask myself which angles have a cosine of 1/2. In order to figure that out, you're going to want to draw the 30, 60, 90 triangle. So I've drawn my 30, 60, 90 right here. And I can see that the cosine of 60 is 1/2. So this has to be some variation of 60 degrees, or pi over 3. But the cosine of 60 is 1/2, so we got to think about the unit circle. If you're in quadrants 1 and 4 and you're talking about cosine, then your cosine is positive. In order for cosine to be negative, then we've got to be into quadrants 2 and 3. So let's draw that real quick. So what I've drawn here on the top right is a quick rotation of pi over 3 because that's 60 degrees. But the cosine of that would be positive 1/2. So I need to figure out, well, I need that same angle rotation, but I need it over here. So what would that be? Well, that would be, if it was pi over 3 from here, that would be 2 pi over 3. This full rotation from the original location to here would be 2 pi over 3. Basically pi over 3 plus pi over 3, or 120 degrees. Well, the same thing is going to happen down here. This will be the same cosine down here, because they're the same vertical position. Because they have the same vertical position, they have the same horizontal position. And that's what I meant to say, they have the same horizontal position. So both of those will have the same cosine. So from here to here would be another pi over 3, making it pi, plus one more pi over 3 from here. This would be 4 pi over 3. So the two places where the cosine inverse is negative 1/2 is 2 pi over 3, but also 4 pi over 3. And actually there are infinitely many more places where that's going to be true, where the cosine is going to be negative 1/2. So that's why this problem is specifically asking us only to look from 0 to 2 pi. I don't care about anything over here in this quadrant or this quadrant because cosine is positive. I need to know where is negative. Cosine is going to be negative 1/2 at these two angular locations. Okay, so from here we have to make what's called a sign analysis chart. So I'm going to create it and then I'll talk about it. Before I create that sign analysis chart, I don't want to forget that the reason that we have these two values of theta here are these are the two values of theta that are going to make the derivative equal to 0. And where the derivative equals 0 has a potential for the derivative to change signs, and that's what we need to know about in order to find our relative extrema and our locations of our maxes and mins. So I've gone ahead and created my sign analysis chart, and what I've done is I've split the interval in question, which is from 0 to 2 pi. I've split it into 3 separate intervals. There's always going to be one more interval than there is solutions to the derivative equal to 0. So when we set the derivative equal to 0, we got 2 solutions, 2 pi over 3 and 4 pi over 3. That means I'm going to use those as sort of like miniature endpoints to break up the interval. And I'm going to have 3 subintervals breaking up 0 to 2 pi because, as you can see, the first one goes 0 to 2 pi over 3, and then starts at 2 pi over 3 to 4 pi over 3, and then the last one starts at 4 pi over 3 to 2 pi. So always going to be one more subinterval than there is zeros to the derivative. Zeros meaning answers to the equation when the derivative was set equal to 0. So from here, what we need to do is we need to pick a number, an input, in each one of these intervals and test it in the derivative and see what sign the number is going to be, positive or negative. So I will select those 3 values. So I've gone ahead and selected pi over 4, pi over 2, and 3 pi over 2. Pi over 4 is somewhere between the first 2 endpoints, 0 to 2 pi over 3. Pi over 2 is between 2 pi over 3 and 4 pi over 3. And 3 pi over 2 is between 4 pi over 3 and 2 pi. So now I've selected those 3 points. I'm going to plug them into the derivative function 3 different times and see the general sign of my solution. Okay, so I've gone ahead and I've set up the derivative 3 different times by 3 different values. But before I keep going, I want you to realize that I made a mistake here. When I had x equals 3 pi over 2, that was not correct. And I needed to change that to pi, and I'll show you why. The values that I pick have to be between these 2 values. So when I picked, actually, hold on. All right, well now I need you to see this again because I actually made a bigger mess than I thought I did. My first value was fine, pi over 4 was fine because, whoops, sorry about that, because pi over 4 is between 0 and 2 pi over 3. The next value was pi, or actually it was, I don't know what it was, but it needs to be pi because pi is going to be directly between, it doesn't have to be halfway between, but it's in between 2 pi over 3 and 4 pi over 3. Pi would be right here. So again, pi over 4 would be right here, which is between 0 and 2 pi over 3. Pi would be right here, which is between 2 pi over 3 and 4 pi over 3. And 3 pi over 2 is right here, which is between 4 pi over 3 and 2 pi. So now that I have my values chosen correctly in the intervals, which shouldn't be that much work, but I'm making a big mess here, I'm going to plug those in and see what the signs are, what the values are as far as positive or negative. So I'm down here, 1 plus 2 cosine of pi over 4 is 1 plus 2 times root 2 over 2, so that's going to be positive. Then I got 1 plus 2 cosine of pi. 2 cosine of pi is 2 times negative 1, so that's negative 2 plus 1. That's going to be negative. And then the last one, 1 plus 2 cosine of 3 pi over 2, that's 1 plus 0, so that's going to be positive as well. So I want to enter those values now in my sign analysis chart. That's all I need. That's all the information I need to start coming up with the rest of these statements to answer the original questions. So we got to remember what the original question was asking us to do. It was asking us to determine the intervals in which f of x is increasing or decreasing, find all coordinates of the relative extrema, and then do this everywhere unless otherwise told to. We're doing it on 0 to 2 pi like they told us to. So we can now say that this function f of theta is increasing from 0 to 2 pi over 3 because the derivative is positive. It is decreasing from 2 pi over 3 to 4 pi over 3 because the derivative is negative. And then it is increasing again at 4 pi over 3 to 2 pi because once again the derivative is positive. So let's make 2 statements, one for where it's positive and one for where the original function is, one for where the original function is increasing and one for where the original function is decreasing. I'll be right back. Okay, so I've written my 2 answers. F of x is increasing on 0 to 2 pi over 3 union 4 pi over 3 to 2 pi because f prime of x is greater than 0 on those intervals. And f of x is decreasing on 2 pi over 3 to 4 pi over 3 because f prime of x is less than 0. So the last part where they want us to do is figure out whether there's a relative maximum or a minimum. So there's going to be a relative maximum wherever the derivative goes from positive to negative, because that means the original function goes from increasing to decreasing. This is going to happen at 2 pi over 3. At 2 pi over 3, right here, this transition, the derivative is going from positive to negative. Therefore, the original function goes from increasing to decreasing, and there is a relative maximum. They also want the coordinates of that relative maximum. So I have to plug 2 pi over 3 into the original function, which I shall do, and write my answer. So I've gone ahead and written both answers. Here we are for the discussion about the relative maximum. So there is a relative maximum at 2 pi over 3, comma, 2 pi over 3 plus root 3. And I found this y coordinate here, that y coordinate, by plugging 2 pi over 3 into the original function and simplifying. You need a little bit of trig background for that. And then I went ahead and I answered the next part too. So I looked back at my sign analysis chart. What happens here at 4 pi over 3? At 4 pi over 3, the derivative switches from negative to positive. Therefore, at 4 pi over 3, since the derivative switches from negative to positive, the original function is switching from decreasing to increasing, thereby creating a relative minimum. So I went ahead and I answered the question for that as well. There is a relative minimum at 4 pi over 3, comma 4 pi over 3 minus root 3. Again, I plugged that into the original function to find those coordinates. Because at x equals 4 pi over 3, f prime of x changes from negative to positive. And it was a similar answer for the relative maximum before. It is because at x equals 2 pi over 3, f prime of x switches from positive to negative. So all in all, a good amount of work here, especially if you're not so great with the trig stuff. But look at all this that we did here just to answer this question. Pretty darn cool, y'all. So we take a look at that. All that is required to answer this question. We determined the intervals of increasing and decreasing right here. So increasing, we determined right here. Decreasing, we determined right here. And then we found out the exact coordinates of the relative maximum and the relative minimum. There's got to be a sign change in one direction or another for those two things to happen. That's all I got for now, y'all. I will catch y'all next time. Take it easy, yeah.